Welcome to another video lesson in abstract algebra, and for today's lesson we are going to talk about splitting fields of polynomials. Last meeting we are interested about a field where a polynomial has a root. Normally, if a polynomial has coefficients in a field f, then and these polynomials doesn't have a root, in this field f, then we know that we can find or we can extend the field f into a bigger field called an extension field in such a way that in this extension field a root can be found. Now in general, if a polynomial is of degree n and we're working on a field, we already know from the factor theorem before that the polynomial can have at most n roots. The question is, what is the extension field, or what is the smallest extension field? Now, when we try to enlarge f into a bigger field, ano kaya yung pinakamaliit na extension field that will contain all the n roots of the polynomial? Pag kasi doon sa field na yun, naroroon yung n roots ng polynomials mo, by the factor theorem, it means to say that your polynomial can be factored into linear factors over that field. Ang tanong, ano kaya yung field na yun, or ano kaya extension field na yun? That's our question. And what is the smallest field where we can factor a polynomial into linear factors? That's the question for today. Okay? Anyway, if alpha is an algebraic element of E over F, then we know that the smallest extension field of F with alpha contained in it, it's denoted by F adjoin alpha. It contains linear combinations of 1 alpha up to alpha to the n minus 1, right? And it's the smallest field containing F and alpha, and is an n-dimensional vector space over F, where n is the degree of the minimal polynomial m of x of alpha over f. Ito yung nagsasummarize ng previous lesson. Diba? Yan yung ginawa natin last lesson. Ayun na nga. Just like what I've told you, a polynomial f of x of degree n has at most n roots. Hindi pa pwedeng lalagpas ng n. Kaya, pwede mong tanungin, parang ganito yun. Halimbawa, meron kang n roots, r1, r2, r3 hanggang rn. Kunwari sa base field, wala yung kahit na anong root yan. Kunwari, in-extend ko to, f of r1. So, nandito yung root na r1, pero hindi ka sure na nandyan yung root na r2. Anong gagawin natin? I-extend pa natin to contain both r1 and r2. Ito naman yung pinakamaliit na extension nito that will contain r2 and itself, of course. And then we will keep on doing the extension until we arrive at some place where all the roots are here. In this case, or over this field, ang maganda dyan sa field na yan, magka-factor yung polynomial mo into linear factors. Ang tawag natin dun, we call it ito na nga yung question. What is the smallest field to contain f and all the roots of f of x? Ayan. Kasi nga, ang kagandahan nun, if alpha 1 up to alpha n are the roots of f of x, and E is the smallest field containing f and these roots, then over E, by the factor theorem, we may write f of x this way. Nakita nyo, degree 1, degree 1, degree 1. O kaya nga ito'y degree n. Kasi ang f square bracket x, kasi ang E square bracket x, kung si E ay field, ay isang integral domain. Kaya nag-a-add yung mga degree n ito. Okay? Itong a na to is just a constant factor, which is a unit. A unit factor. Ang tawag natin sa field where the smallest field where this thing happens is called the splitting field. Anyway, kaya nga splitting field kasi the polynomial splits into linear factors. Yun yung terminology. So here, f is a field. F of x is a non-constant polynomial. if E is a field extension of F, we say that f of x is splits over E if F factors into linear factors. Like so. Hindi ko nababasahin, no? In particular, we call E, kasi ganito eh, pag nag-split na yung f of x over E, mag-i-split na rin siya sa lahat pa ng extensions ng E kasi parang redundancy na lang naman yung mga dadagdag mong elements, right? Intindihan nyo? Gusto nating malaman, syempre, mathematicians like to economize. We would like to get the smallest field where this can happen or saan nagfa-factor into linear factors ang isang polynomial. Yan. Tawag doon splitting field. We call E a splitting field for f of x. If f of x splits over E, and whenever k is a field extension of f smaller than E, then f of x does not split over k. Naintindihan niyo? Kung meron mang extension si f na mas maliit sa E, hindi doon nag-split si f of x. Kaya nga, si E yung kauna-unahang pinakamaliit na extension field where f of x splits. Okay? Now, of course, the splitting field, alam naman natin kung ano yung splitting field, no? The splitting field of f of x over f is the field f adjoin alpha 1, alpha 2, up to alpha n. Diba yung notation na ito means the smallest extension field of f that contains all of the roots. Ang tanong, paano yung ginagawa? Ganito, kung meron kang dalawang elements, ganito lang yan. Ito yung drawing ko kanina. Parang ini-extend mo from f. Akit ka ng isa, f of alpha 1. From here, extend mo ito, f alpha 1. Tapos, i-adjoin mo yung alpha 2. Meron kang ganito. Ito naman, parang ito, i-extend mo by adjoining that. Kasi kung paano natin ginagawa yung ito, vector space ito, diba? Simple extension. Pinag-aralan natin last meeting kung paano ito kino-construct. Kung alam mo kung paano ito kino-construct, alam mo kung paano ito i-construct. Ito lang yung gagawin ng base field. No? Huwag natin tawaging base field because a base field is used differently. May operational meaning yun sa abstract algebra. Sorry. Anyway. Ito naman yung paanan mo ngayon. Mag-extend ka ng isa inductively until makarating ka dun. Alright. May tanong ako. What is the degree of this? When you say degree, this is an extension. No? This is an extension of Q that contains the element the square root of 2 and square root of 3. Of course, because this is a field extension, this is a vector space over Q. By the degree, we mean the dimension. What do you think is the dimension? Well, as you can see, Q adjoin square root of 2 square root of 3 is Q adjoin square root of 2 adjoin square root of 3. Naintindihan nyo? Parang in-extend natin si Q into here. Ito ngayon yung gagawin ng paanan. Ito ang i-extend mo ngayon to contain the elements Q square root of 3. Pero alam nyo na ang mga elements nito, kasi ang square root of 2, ang minimal polynomial niyan ay degree 2, diba? X squared minus 2. Kaya, ganyan ang itsura ng mga elements. Okay? Hence, every element of this must be of the following form. Linear combination siya ng 1 tsaka square root of 3. Pero ang gagamitin mo scalars mula dito. Kaya ganyan. Nakuha niya? And when you simplify, ito yung kalalabasan ngayon. Kita nyo yung 1, square root of 2, square root of 3, tsaka square root of 6 linearly independent yan. Kaya nga, masasabi nyo na ito yung actually basis doon sa vector space na to. At ang degree ay 4 because meron kang 4 elements that span. In reality, ganito yung nangyari. Ito yung Q, no? Ito yung Q square root of 2, in-extend natin ng isa. Meron din namang Q square root of 3. Yun nga hindi natin alam kung right? Square root of 3. Nasaan na yung, so ito, nandun, nasa loob. Nasaan na yung Q square root of 2, square root of 3. Nandito yun. Yung Q square root of 2 comma square root of 3 contains both of this. Parang ganyan yung tower of fields, no? Dimension 2, dimension 2, ito dimension 2, dimension 2, kaya ito dimension 4, dimension 4. Naintindihan nyo? Okay. So may tanong ako, ito na. May polynomial ako ngayon. X to the 4th minus 5x squared plus 6 over q. What is the splitting field of f of x? So you will try to, pag sinabing splitting field, titignan nyo kung mag-factor ito over q. Over q, nag-factor ito. Ito ganyan. Pero over q, hindi mo na ito ma-factor. Irreducible na itong dalawa. Right? Pero of course, we know that over a given extension, pwede mo pa i-factor into linear factors like so. Hence, the splitting field of f of x over q must be q adjoin all of these roots. Q square root of 2 minus square root of 2, square root of 3 minus square root of 3. Pero alam nyo, dahil nga field ito, no? Pag nandun na yung square root of 2 by the closure property, nandun na yung negative square root of 2. Meaning to say, this is just a redundancy. Pag naroroon na rin yung square root of 3, nandun na rin yung negative square root of 3. So, this is basically a redundancy of the following. So, you can always write this as follows. So, yung example pala natin nakaraan, yun yung splitting field ng x to the 4th minus 5x squared plus 6. How about the splitting field of x squared plus 1? Over r, hindi nga nagka-factor ito, di ba? No? Pero magka-factor ito over c. Nag-split yan over c. Pero hindi mo kailangan lahat ng complex numbers just to factor this one out into linear factors. You only need the rational numbers and the element I. Tama ba ako? Kaya ang splitting field nito ay yung q adjoin I. Ano ba pinagkaiba ng q adjoin I sa r adjoin I? Well, ang q adjoin I, alam mo nito yung mga a plus bi, where a and b are rational numbers. Paano ko nasabing a plus bi lang? Kasi ang I, ang minimal polynomial ng x squared plus 1 over q. Degree 2. Kaya nga, meron ka ng dalawang scalars, a and b. Pag degree 3, meron ka pang isa, plus ci squared. Kaya nga lang, in this case, yung i squared negative 1, naging constant na lang siya. Sumasama siya dun sa a. Naintindihan niyo kung paano ginagawa yung extension field, okay? Ito na nga, parang kanina rin. Pag nandun na kasi yung I, nandun na rin yung minus I by closure. Kaya nga, you can simplify it into Q, parenthesis I. Burahin ko nga ito. On the other hand, the splitting field over R of x squared plus 1 is R adjoin I. Pero ang R adjoin I, this case, is already, ano ni R adjoin I? Is already the field of complex numbers. Kasama na lahat. So, A and B are real numbers here. Pero ito, mga A and B rational numbers. May mga elements ito na wala dito. Example, yung, halimbawa, 1 plus square root of 2i. No, ito yung nasa R adjoin I, pero wala siya sa Q adjoin I. You get that? Okay. Ito. What is the splitting field over Q of the polynomial x cubed minus 1? So, titignan nyo. Alam nyo, over Q, nag-factor ito. Hindi siya irreducible. In fact, it's x minus 1 times x squared plus x plus 1. Pero you can check, no? Itong polynomial na ito is already irreducible over Q. So, sabihin, ito na yung most na magagawa nating factorization over Q. So, in order to factor x cubed minus 1 into linear factors, you need an extension of Q. No? And what extension is that? Ang gagawin nyo, isa-solve nyo yung mga roots na ito. Equate nyo sa 0. Pwede kang gumamit ng quadratic formula. Makikita nyo, pag ginamitan yung quadratic formula, imaginary or complex, imaginary ang mga roots na ito. Okay? Well, hindi naman kailangan i-solve. Alam natin, no, na meron niyang root in some extension. And by the fundamental theorem of algebra, alam natin na hindi lalagpas yun sa C. Lahat ng polynomial nagsasolve sa C kasi. Diba? So, if omega is a complex number, is a complex root of x squared plus x plus 1, then it is also a root of x cubed minus 1, right? So, kung root ka ng x cubed minus 1, so meaning to say, ano to? Cube root of 1. Cube root of unity. Complex number pero cube root ng 1. Ano man yon, meron naman kayong quadratic formula to get the exact value. But here, we don't need that. No, si omega, ito ay root nito. So, isabihin nun, ang omega squared plus omega plus 1 ay 0. Right? By the factor theorem, itong root polynomial ito, linear polynomial na ito, mag-factor siya nito. Right? Gagamit ako ngayon ng synthetic division. Paano yun? 1, 1, 1. Kukunin ko to. Ba't ako gagamit ng synthetic division? Para makuha ko yung other factor, linear factor. 1 times omega, omega squared. This is 1 plus omega. This is omega plus omega squared. As you can see, yan dito, 1 plus omega squared. Sabi ko nga, si omega ay root kasi nito. So, ito ay 0 na. So, what's the other factor? The other factor is ito. X plus 1 plus omega. Right? Pero may mas madaling paraan to write this. Kasi nga, ang 1 plus omega squared ay 0. Ang 1 plus omega ay equal lang sa minus omega squared. Kaya pwede nyo rin isulat ito as x minus omega squared. Okay? Nalilito ba kayo? Ganun talaga sa umpisa, pero makakasanayan nyo. So, if x minus omega is a factor of x squared plus x plus 1, the other factor is x minus omega squared. So, actually, ang roots nung x cubed minus 1 ay 1, omega, kung sino man yung omega na to, tsaka omega squared. Yan. Kaya nag-factor ito in the following. Correct? Correct. Yes. Hence, the splitting field of x cubed minus 1 over q is q omega squared. Yung 1 kasi na ito, nandun na yan sa q. No need to adjoin it. Ang isasama mo na lang yung omega tsaka omega squared. Pero alam nyo, dahil nga field ito, kung yung omega nandyan na, yung omega squared, nandun na rin. Kaya you can just write it as q of omega. Ano ba yung omega na yan? Well, you can calculate actually. Ito siya di ba? Ito equation, so solve mo. A, B, C, pare-parehas 1. So, by quadratic formula, kunin lang natin yung positive. Negative 1 plus square root of b squared minus 4ac, 4 over 2. Negative 1 half plus square root of 3 over 2i. Yun yung omega. Ang omega squared mo ngayon, yung other root, which is hindi ko lang sinulat, pero hindi naman kasi natin kailangan malaman yung exact value ng omega. We know that it exists in some extension. Here, in this case, nandun sa C. No? Omega, ito yung omega squared. Kung titignan nyo yan sa complex plane, kung ito-draw nyo yung complex plane, ito yung x-axis, ito yung y-axis, ito yung 1, makikita nyo ito yung 1, yung omega nandito yan. Negative 1 half plus squared, 60 degrees ito. Ito 60 degrees ito. Tapos yung omega squared nandito. 1, omega squared. Mapapansin nyo lahat sila ay makikita sa unit circle and they divide the unit circle into 3 equal parts. Okay? Property yan ng mga nth roots of unity. Ito, cube roots of unity kaya 3. One last question about this example. Anong degree nung q of omega over q? Anong degree? Diba? Ano to? Ito yung degree nung minimal polynomial. Pero ano yung minimal polynomial? Ang minimal polynomial yung x squared plus x plus 1. Hindi x cubed minus 1. Although it's a root of x cubed minus 1, but x cubed minus 1 is not irreducible. Remember that the minimal polynomial is the unique, monic, irreducible polynomial that satisfies the that makes the element 0. Kaya ito yung degree 2. Kaya nga, ang laman talaga ng Q adjoin omega, mga ganito lang, A plus B omega, where A and B are rational numbers. Okay? Degree 2 lang pala kasi siya. Okay? One last example before we dive into the theory. Now, what is the splitting field of x cubed minus 2? Ito iniba. Over Q. Kanina x cubed minus 1, no? Ngayon kaya x cubed minus 2. You can check that by Eisenstein criterion, this is irreducible over Q. Or you can just look at the possible rational roots of this polynomial. Ang possible rational roots na ito ay mga divisors ng 2 plus minus 2. Pero none of them will make the polynomial 0 when you evaluate. So, by the rational root theorem, wala itong rational roots. Hence, dahil degree 3 ito, irreducible siya automatic. Di ba ganun yun? Pag degree 3 or 2, tapos wala kang root, it means irreducible. Again, I apologize for the unnecessary noises. May bumibusina doon sa labas kasi. So, talagang over Q, hindi natin ito ma-factor in anyway. No? Pero we will attempt. Kasi, tingnan nyo ha, when you equate x cubed minus 2 to 0, you can solve for x. X is the cube root of 2. May real solution ito. Cube root of 2, right? Pero dahil ito yung degree 3, ang katotohanan niyan, meron siya talagang tatlong root. Wala nga lang sa R. It's in a bigger extension. So, nasa complex plane. Tingnan nyo ha. Observe that we may write x cubed minus 2 as 2 times u cubed minus 1. Where u can be adjusted as x over cube root of 2. Tama ba? Yes, no? Algebra lang to. So, ang mga roots na ito, bale, pag ito in-equate mo, magiging 0 ito if and only if u cube minus 1 is equal to 0. So, kukunin mo ulit yung cube roots of unity. Kanina ang cube roots of unity. Anong cube roots ng unity? 1 omega omega squared. Yung omega ito. Kinampit natin kanina. Okay? So, kung yun yung mga roots ng u cube minus 1, so kung mga u mo tatlo, 1 omega omega squared, ano yung x? Eh ang x mo, 'di ba, from this equation, x is cube root of 2 times u. So, yung mga roots na ito, ta-times mo lang ng cube root of 2. Kaya yung roots ng x cube minus 2 ay cube root of 2. Ito yung 1 times cube root of 2. Cube root of 2 times omega at cube root of 2 times omega squared. Okay? Hence, x cubed minus 2 factors into this. Therefore, the splitting field over Q of x cubed minus 2 is this. Pero nakita nyo, no? Merong mga elements dito na prominent. Yung cube root of 2 tsaka yung omega. Diba, kapag ang field, it contains cube root of 2 and it contains omega, it contains this product and this product. Hence, you can simplify this field extension as the field extension Q cube root of 2 omega. Okay? Question, anong degree nung extension na ito? Or anong degree nung, extension na ito? What do you think is the degree? Tignan natin. At si Q, ito munang Q cube root of 2 adjoin. Anong degree ng extension na ito? Anong minimal polynomial ng cube root of 2? For cube root of 2, minimal polynomial sa x cube minus 2. Kaya ito yung degree 3. kung i-extend mo ulit ito into Q, cube root of 2, omega, ang minimal polynomial ng omega over this, real pa rin naman ito, ay x squared plus x plus 1 degree 2. By Tower law, ano yung Tower law? Multiply mo yung 2 and 3. Yun yung dimension, no? So this extension is a degree 6 extension of Q by Tower law. Hanapin nyo yung Tower law. Diniscuss natin yan dati. Okay? So ito na. Punta na tayo dito sa mga theoretical eklavu. First of all, meron tayong gagawin lang. No? What we wanted to do next is just to show that a polynomial, basta non-constant siya over a field, lagi kang may mahanap na splitting field. Or in other words, sure ka na mag-exist yan. In other words, any non-constant polynomial will factor into linear factors in some field extension. Guaranteed yun. And there's a smallest field extension where that will happen. In other words, that exists. The next thing, ito yung mas mahirap na portion. Ipapakita natin that splitting fields are actually unique up to isomorphism. Ibig sabihin nun, kung nakahanap ka man ng dalawang splitting fields for a polynomial, isomorphic lang sila. Okay? Ayun yung mga natitirang. Kung ayaw nyo nang pakinggan yung mga theoretical proofs, no, you can already end this video kasi yun lang ang mapapanood nyo sa mga susunod. No? Pero, of course, as math majors, you have to know how these proofs are done. So, let's write the proof for the existence. Existence muna tayo. Ang gagawin lang natin, we will proceed by induction on the degree of p of x. If p of x is linear, tapos na. F suffices kasi linear lang siya. Nag-factor na siya into linear factors, trivially. So, si F ay splitting field na. Okay? Assume that n is greater than or equal to 2 and that the conclusion holds in the n-1 case. We will prove that the conclusion also holds in the n case or the case, in the n case. Dahil nga UFD, si F square bracket X, ang UFD, unique factorization domain. Pwede mong isulat si P of X uniquely in the following manner. G1 of X times G2 of X and so on up to GK of X where each GI is irreducible. Diba ganun yun? Nag-factor into irreducible polynomials over a field ang isang polynomial. Not necessarily linear. Basta ito yung mga irreducible. By a previous theorem, may extension field si F, tawagin natin E, in which yung G1 of X, yung unang irreducible polynomial, has a root. Hence, in this extension, over this extension, nagka-factor yung G1 of X into the following by the factor theorem. Okay? Kaya yung P of X mo ngayon, pwede mo nang isulat ng ganito. Yung G1 of X was replaced by the following. Now, linear ito. Si P of X ay degree n. Okay? Anong degree na ito? Yes, degree n minus 1. By induction hypothesis, this one splits in some extension field K of E. Therefore, tapos na. Therefore, P of X itself splits over K as well. And on K, we may write P of X as follows. Thus, the smallest field to contain F and all these alphas is a splitting field for P of X over F. We're done. Ganun na kadali existence. Ang mahirap ipakita dito ay yung uniqueness. And in fact, mahaba talaga yung details, pero I will try to simplify it for you. Yung mga details hindi ko na ipapakita, pero at least ipapakita ko sa inyo how the proof was done. Next, sabi ko nga, ang intention natin is to prove that splitting field of a non-constant polynomial is unique up to isomorphism. Meron tayong notation na gagamitin. If Phi is a ring homomorphism from R to S, and P of X is a polynomial whose coefficients are from R, pag in-apply ko yung, ang totoo, hindi mo ma-apply si Phi sa P of X, diba? Kasi yung P of X ay polynomial over R, hindi naman siya element ng R. Pero kapag in-apply ko yung homomorphism na Phi dun sa polynomial, ang ibig sabihin ko nun, ina-apply ko yung Phi sa lahat ng mga coefficients, okay? Like so. And then, therefore, forming a polynomial in S squared bracket X, kasi lahat ito ngayon nakarating na sa S. Ipapakita natin sa susunod na lemma, no? Yung homomorphism na to extends to a ring homomorphism in the ring, parang ganito yan eh. Pwede mo kasing isipin na si R nasa loob ng R squared bracket X, right? Pwede mo ring isipin si S as parang nasa loob ng S squared bracket X. Kung ito si Phi, pwede mo raw isipin si Phi, or pwede mo siyang i-extend in some way to become a homomorphism from R squared bracket X to S squared bracket X. Ayan na, nagdodrawing na tayo ng mga diagrams. Alam nyo na, kapag gumagamit tayo ng homomorphism, sabihin we are diving in the theoretical part of the study. But this is just part of the process, no? Hindi nyo dapat katakutan. This is how mathematical minds work. Alright, ito na nga yun. Ang tawag dito ay isomorphism lifting lemma. Actually, ako lang tumawag na ito. Naririnig ko yung lifting lemma somewhere. I don't know kung sang reference book ko siya nabasa. Pero, yeah. I've read it somewhere and I have restated it in my way. Ito yun. If Phi is a field isomorphism, so this time, F and K are fields kasi nga gagawa tayo ng mga polynomial rings. And P of X is irreducible over F. So, yung mga coefficients ng P of X nandito sa F, no? If A is a root of P of X in some extension field of F, and B is a root, di ba may P of X ka dito? Right? Yeah. Nandito yung phi of P of X. Parang in-apply mo yung phi sa mga coefficients ng P to get another polynomial over K. Okay? Ito nasa K square bracket X na ito. Then, sabi natin, meron daw nag-exist na isomorphism from, tawagin nating phi bar. Parang in-extend ni phi bar si phi in a way na ito yung nagiging isomorphism din siya from this extension towards this extension. Ito yung smallest field to contain F and the root A of P of X. Ito yung smallest extension ng K to contain K and the root B of phi of P of X. In fact, yung isomorphism na ito, yung field isomorphism niyan, it simply copies the action of phi. Basta nandun ka sa F. Ibig sabihin, si phi bar, si phi lang naman din talaga yon. Kaya lang, nag-extend lang yung definition niya in a way that it maps A towards B. Naintindihan nyo? So really, si phi bar ay si phi lang naman din kung nandito ka lang. Pero pag in-extend mo siya dito, it does some magic. Kasi si A, pinapadala niya sa B. Ganito yung proof, no? Medyo yung diagram kanina, no, ibubuka ko ng konti. Kasi may gagawin tayo. Si P of X ay irreducible, no? Dahil nga field isomorphism yung alpha, but alpha ito? That should not be alpha. Mali ako ng type. That should be phi. Sorry. Yung alpha here should be phi. Nandito na ako sa notation. That should be phi. Dahil nga si phi ay field isomorphism, dinadala niya yung mga bagay dito into here nang hindi binabago yung property. So, meaning to say, itong polynomial na to can be shown to be irreducible as well. In fact, pag ginawa mo yung quotient rings na ito, filled yan. Kasi si P of X ay irreducible. So, yung ideal na ito ay maximal. So, pag ginawa mo yung quotient ring na ito, yan ay filled. Diba? In fact, ito yung field of cosets kung saan nakita natin yung zero nung polynomial na P of X. May zero yung P of X dito sa quotient ring na ito. Right? At alam natin na yung quotient ring na yan by the previous video lesson, ito ay isomorphic. Diba? Itong dalawa, isomorphic. Itong dalawa ay isomorphic. Ano yung isomorphism? Yung alpha, ito. Itong coset na ito, nakikita nyo, ito ay ideal generated by P of X. Ito yung mga multiples ng P of X. Set ito. Ito yung coset that contains f of x. Ang laman nito yung mga polynomials na ang remainder ay f of x pag dinivide sa P of x. Ganun yung imaginein. Pwede nyong ipadala ito. Pag pinadala nyo ito sa, transform ito sa f of a, mapupunta ka dito. Ayan yung alpha. Phi ito ha. Yung beta naman pa ganon. Ito yung ideal generated by alpha P of X, irreducible to kaya ito field. No? Ito ay isomorphism. The fact that these are isomorphic or that these are isomorphism are from the previous lesson, previous video lesson. Pinag-aralan natin last time. Next, we will try to show that there is a field isomorphism that goes from here up to there. Pero gamma ang pangalan ko, no? Pero paano kino-construct yung gamma na yan? Ganito. We will first consider the map tau. Wala dito yung f square bracket x. Don't look at the diagram. We will construct the map tau from f square bracket x, mga polynomials ito, to this ring of cosets in this manner. Pag may polynomial f of x ka, no, sa f square bracket x, dadaling ko to sa coset neto, no, that contains this element phi of f of x. Medyo complicated yung definition niya, pero makikita nyo using computations na ito ay ring epimorphism. When I say epimorphism, it's an onto or surjective. Sabihin yung image mo ay yung buong quotient ring na yan. Field siya actually, no? Alright. Kasi ito nasa k square bracket x to di ba? Okay? Okay, yun yung mga details na hindi ko na ipapakita, no, na ring epimorphism. Ang kernel nito, you can check, is the ideal generated by P of x. Hence, by the fundamental isomorphism theorem, isomorphic yung f square bracket x modulo the kernel, ang kernel ito, dun sa image. Ito yung image. Kaya meron kang makikitang isomorphism from here to there. Tawagin mong gamma yun. Yun, ito na. Ang gagawin ko ngayon, ito na yung diagram, no? I-reverse ko yung alpha. Isomorphism so bijective, meron siyang inverse na isomorphism din. I-reverse ko yung alpha, babaliktad yung arrow, that's alpha inverse. Iko-compose ko siya with gamma and beta. Makakagawa kayo na ko, yung composition na ngayon yun. Makakagawa ko ng phi bar. Okay? Pag ginawa mo yung composition na ito, composition of isomorphisms is an isomorphism. So, it's an isomorphism from FA to KB. Ito, I just leave this to you to check that actually phi bar of C is phi of C basta si C ay nasa F. Makikita niyo sa mga may definitions ako ng beta, gamma, and alpha inverse, diba? So, i-check nyo isa-isa. And then, ma-check nyo rin ang phi bar of A is equal to B. Ano ba yung theorem? Well, ito yung extension ng or I mean particular case nung lifting lemma. Let phi be an field isomorphism from F to K and let P of X be a non-constant polynomial. If L is the splitting field of P of X over F, and M is a splitting field of alpha P of X over K, then phi extends or lifts to an isomorphism phi bar from L to M. Kasi nagawa mo siya sa isang root di ba? Yung lemma natin, nagawa mo siya sa isang root. Parang ganito si F, si K. Kunwari, yung P of X dito, may roots na alpha 1, alpha 2, alpha n. Wag alpha. Let me use A. A1, A2, AN. So, si phi of P of X dito, kunwari, may roots na B1, B2, Bn. Ito si phi. Nandito yung f of A1, nandito yung f k of B1. May extend mo to into phi 1, di ba? Sabi ng lifting lemma. Extend mo ulit ito. A1, A2, K, B1, B2, ganyan. May extend ulit yung phi 1 into another field isomorphism phi 2, and so on. Hanggang makarating ka dun sa splitting field. The splitting field contains all the roots. Alright? Kaya nga, mag-extend siya hanggang makarating ka dun sa L at M. Kaya na nga, apply isomorphism, lifting lemma, and induction. And as a corollary, if F is a field and P of X is a non-constant polynomial over F, any two splitting fields of P of X are isomorphic. Kasi nga, dahil dito. Ma-extend mo kasi yung pag kumuha ka ng dalawang splitting field ng P of X, gagawin nyo lang, yung phi doon sa theorem, gagawin nyo lang identity mapping, which is an isomorphism, of course. Kasi wala kang dalawang polynomial, isa lang yung polynomial mo. Ang mapping mo, f square bracket x to f square bracket x. Naintindihan nyo? That's it. So, in the next video lesson, we will be studying fields which have finitely many elements, no? Gaano kaya kadami ang elements ng isang field? Tignan nyo na kung anong ibig sabihin ng perfect fields, no? Mababanggit din sila in the next lesson. Okay? Till next time. See you.